So in this video, we are going to get ourselves familiar with some of the polar graphs here and see how they plot out. So here we have the rectangular graph versus the polar graph. So theta is our x and r is our y. And I'm going to go ahead and animate this and watch how this draws. So the tip of the arrow here corresponds over here. So notice when we had negative radius, that was the bottom half of the circle. And then also notice this does one revolution around the circle in pi units. So that was a circle. Can have a limicon. So this is a limicon with a loop. So notice it starts out here on the positive x-axis. When it's doing that inside loop, that's when r is negative here. And then this last half is when r is positive. Limicon along the y-axis. It's a sine theta. So along our circles here are like r equals cosine theta and r equals sine theta. If it's sine theta, it's along the y-axis. Our limicons, if it's a cosine theta limicon, so this would be 3 cosine theta plus 1.5. It's along the x-axis, so symmetric with x. If it's a limicon along the y-axis, it'll be sine theta. And the important thing is that the coefficient of the trig function is twice the size or bigger than the constant out there on the end. So this starts from here and goes around, and then again the inner loop is right here. It's where radius is negative. And then a cardioid, curve that we want to be familiar with. So starting here and rotating around. So here, rotating around 0 to 2 pi. Radius never negative there. Okay, call it a cardioid because it looks like a heart. So here, 1 minus cosine theta, the coefficients are the same. If it was a sine theta cardioid, it would be along the y-axis. And then roses. So here they're looking at a fairly complicated rose curve. This one doesn't do a good job of showing how to graph that rose curve. Let's take a look at another demonstration. Here, actually, let's look at one more curve. So that was our butterfly curve. So notice here you got some positive radius, a negative, another negative, and those negative radii. It's hard to tell here. So there's a positive. Let's see, when our radius went negative here, yeah, we were going on this loop here. And when our radius went negative back here, yep, we're going on the smaller loop. So the smaller loop there is when radius was negative, and then negative here and negative here, that's that last loop. So the positive radius are the bigger loops, and the smaller radius are, the negative radius is the smaller loops. So here's another demonstration. So here we'll go ahead and have it plot. This is r equal cosine theta. That's going to be a circle along the x-axis. Okay, so again, this is 0 to 2 pi, but you can see starts at the positive x-axis, goes counterclockwise. It's cosine theta. R equals sine 2 theta. That is a 4-leaf rose. So, or 4-petaled rose. And it does that inside of 0 to 2 pi. So notice here this is 2 theta, and we've got 4 petals. So whenever that coefficient of theta is even, you got twice that number of petals. With a cosine 3 theta, we've got 3 petals. So if the coefficient of theta is odd, that's the number of petals. And 1 minus sine theta, that's a cardioid along the y-axis. So again, starting from positive x-axis and going counterclockwise. 1 plus 2 sine 4 theta. So this one's kind of crazy. It's got some positive and negative radius in that graph. And we're seeing kind of petals between petals there. And 1 plus cosine 4 theta, or I'm sorry, 4 cosine 5 theta. That one's kind of interesting. You're getting petals inside of petals. And it doesn't quite draw things in the order that you think. Sine theta over 4. That's kind of a fun curve. And then sine 8/5 theta. Now that's looking like spirograph. Okay, so all these curves can be described by polar or parametric equations. And then the last one, that's kind of crazy. It looks kind of like a butterfly's wings to me. Notice we've got the y-axis symmetry there. So the ones that I want you to be familiar with are on the polar graph summary sheet, and this is at the end of the week 1 module, or I'm sorry, this week's module in Canvas. So a times sine of theta, that's a circle along the y-axis. A cosine theta, circle along the x-axis. A is the diameter. R squared is a squared sine 2 theta. That is a lemniscate, or a figure 8 on the diagonal. A squared cosine squared 2 theta, that's your figure 8 that's along the x-axis. Also cardioids. So a plus or minus b cosine theta, where a equals b. So if it's a cosine theta cardioid, that's along the x-axis here. If it's a sine theta cardioid, that's this one along the y-axis. And then one loop limicon's just got a dimple here. It's like a cardioid without a dimple. Same form for the equation. It's just that a over b has to be between 1 and 2. So a is bigger than b, but it's not more than twice as big as b. And so the cosine theta limicon is this one along the x-axis, and the one that's symmetric with respect to the y-axis, that's your sine theta limicon. And then limicon with a loop, that happens when a is less than b. So it's going to start out here, go around this inside loop, and then finish up. The sine theta limicon, that's going to start down here on the x-axis, come around like this, go around that little inside loop, and then come back to here to the start, and then you're doing it again. And then roses here, a cosine n theta or a sine n theta, where n is even. You'll have 2n leaves or 2n petals. And the difference between the cosine n theta and the sine n theta is one of them is shifted on the 45-degree line. So it has the petals going along this line and along this line. And then the other is symmetric. Petals are along the x and y axis. And then if you've got sine n theta, cosine n theta, where n is odd, then that is the number of leaves or number of petals in the rose. So this is actually a 3 theta, because you've got 3 petals, and it would graph like that. So, okay, so feel free to print off that polar reference sheet or keep a copy handy. That'll help you in doing problem number 9 in WebAssign, and also be handy on the exam.